Okay, welcome to the first set of notes on Chapter 1, Section 2. There's some just important things to notice. You'll see on the calendar. There's the objectives that we're going to cover today, and then there's notes and then practice. And this goes throughout the calendar all the time. There's videos to help you if you want them down there, and then a breakdown of the days and everything like that. If you have any questions on the calendar, let me know. Let's take a look at what you guys have. You guys have a handout that has some words or phrases here, a spot for you to put some definitions. We'll try to keep those brief. How to sketch in an example sketch, and then how to name and or label. So you have all these things. The notes will go pretty quickly. Pause it where you need to, and take more time to make sure you're getting anything written down. But this is all the stuff you have. And then we'll answer some questions at the end, and do some practice problems on our own. So these are just the notes that you have that you're going to work your way through, and then I'm going to kind of work them one thing at a time. Okay, so Unit 1 says Day 3. Pay no attention. All right. Let's take a look at points, lines, and planes. So points don't have an actual size. A point is a single location in space. We sketch a point very simply using dots. We label them with capital letters. That seems like maybe a little thing, but we want to, that's a big deal. We want to make sure that we're labeling with capital letters, okay? And that we never name 2 points with the same letter. So this right here, this is not good. We've already used that letter in this sketch, so we want to make sure we use C instead. So pretty simple there with points. Let's take a look here at lines. Lines extend indefinitely and have no thickness or width. Indefinitely means forever, right? So forever in both directions, that's what the nice little arrows here at both ends mean. You have to sketch them with the arrows at both ends. If you don't, it's not a line. It's either a segment or array, which we'll get to in a little bit. We can name lines 2 ways. We can name them with just a small little script letter, like we have right here with just N. Or we can name them with 2 points that are on the line, like using A and B, B and C, AC, BA, all these different examples. We never name a line using 3 points, okay? You only need 2 points to name the line. Pretty simple stuff there as well. A segment. A segment is a part of a line that has 2 endpoints. There's no letter there. A segment is a part of a line that has 2 endpoints. So I magically made the S appear. All right, so how to sketch that? Really just a dot and then a couple capital letters for each of the points. And then we name the segment with just the 2 letters that it has. And then there's no arrows, you'll notice. These are just a little short segment, a little bar, so to speak, above the letters themselves. So easy stuff there as well. Array. Array is a part of a line with 1 endpoint and extends forever in one direction. So it stops at one side, and then the other side goes forever and ever and ever. How to name these? You can name them in either order. The key is where the arrow goes. You'll notice that the arrow here is over the B, whether the B is listed first or second, and that's on purpose because that's the side that goes forever. With this ray, we have 3 points on this ray, so we can name it DF or we can name it DE. It just matters that the end point is over here above the D because that's the side where it stops. DEF is not correct. We don't use all 3 letters to name a ray. Opposite rays are 2 rays that share the same endpoint and therefore they form a line. Okay, so AC going in this direction and then AB going in this direction. So AB is going that way and then AC is going that way. They meet and share a point at A, and because of that they're opposite rays. BA and AC are not opposite rays because they go, you're dismissed. BA and AC are not opposite rays because they go at each other. Okay, so they have to share the same endpoint, which BA and AC obviously do not. Collinear points. Okay, collinear points are points that lie on the same line. The line doesn't have to be visible. We don't have to be able to see it, but it makes it useful for us. So collinear points look like this. A, B, and C, those points are all collinear. Non-collinear points are points that don't lie on the same line. So I can't draw one line through A, B, and C here. Now, some people are saying, well, yes, you could. You could draw, a line like this and get through all 3. Well, that's not a line. A line extends forever in both directions and never changes direction. So that's not a line. We must name at least 3 points for them to be not collinear, because through any 2 points, no matter where they are, I can always connect those and make that into a line. Moving right along. Postulate. You're going to hear this word a lot this whole year. Okay, a postulate. Math teachers like sounding fancy. It's known as an axiom. That's a synonym for it. It's just an accepted statement of fact. It's a math fact. That's all you really got to know there. Postulate is a math fact. All right, now we have planes. A plane is a flat surface that extends indefinitely in all directions. We use a parallelogram to sketch it. Obviously, we can't sketch what a plane actually is, because if it goes indefinitely in all directions, we would run out of lead or ink or whatever. We can name planes 2 ways. We can name planes using a capital script letter M, like for example here, or we can name them using any 3 non-collinear points on the plane. So these 3 points are all on this plane. We could use those to name the plane. Different planes in a figure. So here's a drawing of a box. There's all sorts of different planes. So ABCD would be like the top, EFGH would be the bottom, BCGF would be this right side, ADHE would be this left side, ABFE is the back, CDHG is the front. So we have all these different planes within this figure. All right. Other planes in the same figure. So we see all the sides of the box, but sometimes we also have, there are other planes that exist that just aren't drawn. So any 3 non-collinear points can determine a plane. So for example, AD down to FG, this sort of like diagonal plane that moves like this, that is a plane. That plane exists. ACH right there, that plane exists. The green one that goes across like diagonally, ACEG, that plane exists. So we can have more planes just because they're not drawn. Any 3 points can form a plane. Coplanar objects. So points, lines are objects that lie on the same plane are coplanar. The plane does not have to be visible for things to be coplanar. So it says non-coplanar objects that do not lie on the same plane. So non-coplanar objects are objects that don't lie on the same plane. Pretty self-explanatory. So let's answer some questions. Take a second, pause the video right here. Take a second and answer these questions. Are the following points coplanar? Pause the video. Do it. Okay, so we're unpaused, and we're going to take a look. Are the following points coplanar? Well, the easy one, ABC and AGF are both easy because there are only 3 points there, so those are both yeses. ABCF, can we draw a plane through A, B, C, and then F? And the answer to that is no. HGFE, yeah, that's the bottom. That's easy. That's a yes. EHCB, EH, and then CB, you could draw a plane diagonally through the box, so that's a yes. CBFH, CBF, and then all the way over here to H, that one's a no. So hopefully you got yes, no, yes, 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 no. Intersection of figures. The intersection of 2 figures is the set of points that are common in both figures. You guys know what an intersection is, but some important facts about intersections. 2 lines always intersect at a point. So line M and line N intersect at point P. 3 possibilities of intersection of a line and a plane. So there's 3 ways they can intersect. The line can pass through the plane. So for example, this red line is going through the plane. Okay? So that intersection of a point, of a line and a plane is a point. If the line is on the plane, like this green one, then the intersection is the line itself. Everywhere that line is, the plane is, because it's actually on the plane. And then if the line is parallel to the plane, like these dark purple lines up here, they're parallel to the plane, there are no common points. So there's 3 possibilities when we have a line and a plane as to how they could intersect. The intersection of 2 planes is a line. So we have this vertical plane here and this horizontal plane here, and they intersect at this red line. So plane P and plane R intersect at the line AB. Some postulates, okay? Some postulates, this is where we're going to fill in some blanks. What I'd like for you to do here is I'd like for you to pause the video again and see if you can answer these questions, and then we'll come back and check them. So go ahead and pause the video, answer what you know, and what you don't we'll fill in together. Go ahead and pause it now. Okay, so you've unpaused, and we're going to look at, so postulate 1-1, through any 2 points, there is exactly one line, okay? Through any 2 points, there's exactly one line. If 2 distinct lines intersect, they intersect in 1 point, okay? 1 point. 1-3 says if 2 distinct planes intersect, they intersect in exactly one line, all right? And then 1-4 says through any 3 non-collinear points, there is exactly one plane. Right? So hopefully you got those right. Let's take a look here. Some things to remember. When you name a ray, an arrowhead is not drawn over the, you got it, the beginning point. Okay. Number 2, when you name a plane with 3 points, choose no more than 2 collinear points. We don't want more than 2 collinear points when you name a plane with 3 points. Number 3, an arrow indicates the direction of a path that extends without end. So when we're dealing with rays, the arrow indicates the direction of a path that extends without ever ending. A plane is represented by a parallelogram. All right. However, the plane actually has no edges. It is flat and extends forever in all directions. All right. What I'd like for you to do here is I'd like for you to pause the video again, use figure A and B to answer the following, and then we'll go over these together. Go ahead and pause the video now. Now. Okay, so you've unpaused the video. Let's take a look at what you got. Where do planes PVD and RQU intersect? Well, they intersect at line ST. Okay, line ST. The horizontal plane and the vertical plane intersect at that line right there, ST. Where do planes HGF and IKJ intersect? Well, they intersect at IF. Okay, they intersect at IF. All right. Where do planes EKJ and GFL intersect? Well, they intersect at LJ. Okay. There's a pattern here that hopefully we're going to figure out on part D. HG, fire drill, be right back. Okay, fire drill over. Good job, everybody. So the pattern that we want to pick up on right here is that where do planes HGJK, so that's this HGJK right here, this diagonal one, and HGIF, where do they intersect? Okay, where do planes HGJK and HGIF, where do they intersect? So hopefully you notice that there are 2 letters that repeat, and the 2 letters are HG. Okay, so HGIF is the top, HGJK is this diagonal one we can't see. They intersect at HG, they intersect at the points they share. Where do planes HGF, EHG, and GLJ intersect? Well, 3 planes intersect in a point, and the common point here in all of those is G. All right, let's take a look at the next page. Identify a segment on figure C using geometric notation. So any segment, the important thing is that you put the segment correctly. It's not a line. So I chose segment KL, but you could have done WX, you could have done ZY, you could have done LK, just as long as it's a segment, so no errors at the end. Identify a ray on figure C using segment notation. I chose XW. Again, it doesn't matter which one you choose as long as it's labeled correctly. All right. Explain the difference between a ray, a segment, and a line. Sorry, this is a little bit small. A ray has one endpoint and extends forever in the other direction. A line extends forever in both directions. And a segment has 2 endpoints. All right. Name 2 opposite rays on figure C. Opposite rays means they share a point. There are none. There are no opposite rays on figure C. Name 3 collinear points from figure A. There were lots of answers here. I chose Q, T, and V, but you might have different answers. Are the points H, J, and G coplanar? Well, any 3 points are coplanar, so that's a yes. Are they collinear? That's a no. That's it for the notes on 1-2. Hopefully it went well. If you need to watch it again, watch it again. And we'll see you next time. Bye.